Good afternoon, everyone. I hope you can hear me loud and clear. Okay, great. Thanks for the confirmation. I am Saurabh. I work for Qualcomm and I lead a team of engineers who basically work for Linux, different kind of Linux distributions that we put upon different Qualcomm SoCs that go to our customers and eventually the market. So my topic today is Ubuntu on Qualcomm Dragon platforms. So I see many of you have been here for almost 2 days and you must have seen our demo booth there where we had the Dragonwing platforms up for demo with different edge AI use cases. What I am going to talk about today, how we transformed ourselves, where we used to generally work on Yocto as our base distribution that we used to support for our Dragonwing platforms and even other SoCs, and how we did a transformation in last 6 to 8 months to even support Ubuntu there. And obviously, the teams at Canonical has been very instrumental to it. They have partnered with us. They have made sure that whatever we do is in a standard way. And it was really working nice with all the people who support Ubuntu as a OS as a distribution. And then a big thanks to the organizers here for organizing this event, and thanks for the opportunity that I can speak here. Thank you, sir. Okay. So I'll get started with a very silly slide. Hello world. Why hello world? I don't think anybody is there in this room who doesn't relate to these two words. Everybody has done something certainly dumb here. That's why you are here. So I am saying hello world because this is our first UbuCon India, and I hope that we can build a better thread where we can do more, where we can talk more, come and collaborate for even longer days and sessions. And another reason I'm saying hello world is we got on Dragonwing developer platform Ubuntu up and running, and we'll see in further slides how this is not a forked version of Ubuntu that we run, but rather something which is distributed a certified way from Ubuntu itself or Canonical itself from the sites wherever they distribute all the assets. Okay. So with that, I won't go very deep into this particular slide. What this slide tries to represent is as a dev kit provider, what we have to deal with. Obviously, you have seen and played with the hardware that is out there. There's a big team at the back end who designs the hardware, even up to the level of SoC. That's our real business. But to get that hardware running and going, and for developers to use every piece of the IP that is there, there are many other pieces that work there. For example, all of you can obviously understand we do have a kernel tree which supports the hardware SoC itself. Ubuntu runs 6.8 version, but we have another Yocto which is running on a very latest and greatest Linux release. Then there are many drivers which we run as out of tree modules which we load and run. And then we have different stacks. If you can see here, we have stack for display, audio, video, and we support both upstream frameworks as well as some proprietary stack that brings the best out of our silicon when it comes to running UI use cases, AI use cases, when a customer really wants to move over and evaluate whether the upstream stack works for me or I can use something proprietary or something that Qualcomm created. That option is available with Ubuntu as well. So this is a representation of that. And then we have the SDKs. We have various SDKs. We have a QNP SDK, which is for our neural processing engine. And then obvious things which any silicon vendor will support. We have the whole boot chain that we support, and the hypervisor technologies, KVM as well as Gunya. I understand for this forum, KVM is of more interest, and we heard that in the previous talk as well. So this is just a snapshot, and we achieved this stack with both Yocto as well as Ubuntu now. So that's what we have achieved very recently with our certified Ubuntu releases, which is up till XO5. Okay. So there's a comparison how we moved from Yocto to Ubuntu as we were on it. So on Yocto, Yocto is a builder's framework. If somebody really needs to define a distribution, they have very niche use cases. For example, in my long career in Qualcomm, when I started, one of the first things that I was involved in was supporting a wearable watch with Linux. Obviously, we can't cram in a full Ubuntu or Android there. We have to choose what we really want. We have to choose an efficient display. We have to choose good audio, still some camera use case. Me work may not be required. So to do that, you need something which you can pick and choose and create a framework or distribution of your own. And for that, Yocto is really a powerful tool. So even today, when we put out Yocto, what we do is we provide obviously all the BSP, what you saw in the previous slides, our bootloader kernel and many different stacks such as camera, graphics, which are our more advanced stacks. But we have a reference distribution which shows how one can pick components, upstream or Qualcomm specific components to define that distribution. It allows you to do that. And as we moved over to Ubuntu, what we have adopted is we have gone over to use standard desktop and server images that Ubuntu provides, and these Qualcomm specific packages that we have shifted to support just as packages. We have hosted them on a PPA, which is on Launchpad, and we have worked out the use case where one can boot with server desktop image and install what they like. Now, that's what we have achieved as we have moved over from Yocto to Ubuntu, and thus included both in our offering. Then on Yocto, we have a collection of recipes. For those of you who are aware, Yocto is basically a collection of recipes in a layer. We have Meta QCOM layer, which is out there on GitHub. Anybody can clone and try it out. So we took those, every recipe that was building a Qualcomm specific software, and we converted them into the Debian packaging requirements that we have. And I noticed later Guru has a session on what is the life of a package from being a source to getting hosted in Launchpad. That will be a really interesting session, so I won't repeat the information here. We covered that technology after technology. What are the complications as a silicon vendor that we saw? We have a very complex set of inter-component dependencies. Yes, so that's what we had to tackle. So to ensure that the experience is seamless for a user when they are working from a PPA. So that pain we were ready to take so that we can reach out to you as a development platform of choice. And then on Yocto, because we are giving a reference distribution, what we also take care is of defining image. Just like Ubuntu has a desktop and server image, we have an upstream image and a proprietary image, which includes all our software components. And we provide a reference OS3 update engine also, which is a community update engine. Whereas on Ubuntu, we have not really gone that way. On Ubuntu, we know the real use case is with APT. We need to use app tools and just install the packages we like. That's what we have realized. Now, I've shared these two QR codes, and intent is for anybody who wants to refer later to show what really it offers. So if somebody scans this one, they would find our Qualcomm Linux page here. And if you go here, this is what we support with Yocto. And the software asset or the repositories that are visible here, for example, these are our graphics driver. And these are in quite active development. You can see from this, graphs that are plotted here that there's heavy active development going on from Qualcomm. That is where we want people to come and engage with us so that these repositories can not just serve Yocto but also the Ubuntu community. So it's our getting more open culture as Qualcomm that we are opening up. Second is Ubuntu on Dragonwing. If you scan this particular QR code and go to the Ubuntu pages, sorry about that, you would end up here and you would see all the demos we have been doing. For example, with the Dragon board evaluation kit or with the Rubik Pi development board, you would find the Ubuntu desktop and the Ubuntu server boot firmware, everything provided for you. And then there are instructions beneath that to really tell how you can, if you procure a Rubik Pi, how you can flash these images and boot and get it working. And just to emphasize again, we are not distributing it. We have got certification and it's from ubuntu.com. That's what everybody likes to do, right? Because then you would know what we have tried to keep intact. There's some certification around it. Okay, there's a quick view which we'll talk about later as to how Qualcomm PPA is serving our camera technology stack, graphics technology stack, or even our QNP SDK for Ubuntu server and desktop use cases. Okay, so thinking packages for Ubuntu. So these are some key things that every single developer inside Qualcomm had to think to basically had a paradigm shift from building from source with all the dependencies also available to building against a PPA. Our developers understood if I want to serve the community better, I have to ensure that my software, even not me, but even anybody in community should be able to clone and compile independently. So we had a significant shift in the way we think about this approach, and we have gone completely modular. Even internal, the development process is focused on packages. One technology area creates its packages, its dev package, bin package, debug package, and hosts it on an internal package server. Another technology teams just screws those, and or rather, I would say, installs those using apt command and compiles the source package only against those. So that kind of isolation is what we have achieved. Uh, Independent per package build, it's not just built by your own, right? It's not good enough to just say that I'm able to run some Debian tool standalone on my own. It's in CI. Sbuild is there. Sbuild runs the CI/CD for us, and then we are able to use package repository to push whatever has been successfully built in a CI/CD pipeline. Thus, not just depending on people, because that can creep in mistakes, but even CI putting checks. And what checks to define that? We have gone more robust on versioning. For every package that we put up in our PPA or even the Launchpad PPA that Canonical hosts for us, the Qualcomm PPA, we follow strict semantic versioning. Packages and libraries that we ship as part of these packages are all following semantic versioning. And then we have ABI and API checkers. There are tools available such as libabgil, which we run to ensure that the ABI is stable as we are shipping new packages out. Uh, Again, dependency management, rather than depending just on make, we have gone very clean. We are using the Debian packaging files to really clearly indicating whatever dependencies are and aligned ourselves to standard. And eventually, even though if packaging is great, package server is what works generally for all developers, what we do realize is at some point you have to have a ability to compose the packages you choose into an image and create a deployable image which you can deploy to the device with ease. So even that is one of the use cases that we keep testing. So this QR leads us to the Launchpad site. I'll just browse through it to show what team has achieved. So if you land up, use that QR code, you would land up here. I'll just browse into pool. And if I go to main under A, for example, I can look up Arduino. Arduino is our graphics stack. Obviously, Mesa Freedreno is what is the open source stack for Qualcomm hardware. But if you want to move over to something which is proprietary, which gives you more access to the features hardware can provide, this is the package that a developer can install using apt command. And you can see there's the bin package there, there's a dev package there, so you can do whatever you desire. And not just Arduino, our QNP SDK, which can be found here just for a purpose of showing where it is. Again, whatever assets we need for the QNP SDK are also on the Launchpad PPA. So this is one of the things that that we have achieved as part of covering this journey.
As a Ubuntu developer myself, I like to help you, sir.
Uh, Versioning, concept of versioning. Yes, thank you. Okay. So open, getting more open. So as I did show earlier while browsing, every repo that we have for interacting with developer, we have put it under this GitHub/Qualcomm Linux. You can go there, browse. If you find a project of your interest, even if it's our kernel project, you can raise issues, you can clone, compile. Our kernel tree is almost against the latest RC tip that is available from kernel.org. And for many of the repos, you would slowly see the packaging files, also Debian packaging files also come up. The intent there is we don't want to lock up people just into one distribution, right? If people like Debian or if people like Ubuntu, they can just use the packaging files that we will host there and use them. Another clarity we have for the developer ecosystem is we need to go upstream, for everything that we support. So if anybody is monitoring various projects or heavily engaged, you would have seen larger participation compared to prior years in kernel development. In some of the other areas, systemd, some contributions are going on. Some upstream projects where you used to carry patches, which we learned from this canonical Ubuntu engagement that it's a pain point for other distributions. We started upstreaming them. Whatever optimizations that they are, we are at least making a good attempt to send it. And surprisingly, if we have a good chat with the maintainer when after sending the patch, we can really most of the times agree on what the use case is, and they do end up taking patches. Even for small things such as where we had just as a case, what we realized, we had a downstream patch in one of the small repos LXC projects, which used to create a directory at build time. We realized it does not work well with OS3. So team members sent a patch to LXC project saying that is there a way to always go stateless and build this or create this directory at runtime at first boot, and which the maintainer understood where we are coming from and they took the patches. So We are taking large steps, obviously, by increasing participation, but even smaller pieces are getting covered. And why so? It's the part of developer centric thought process, right? If we carry few patches at our end, people will have easy time understanding what we do. So that's we are trying to cover. Okay, so this is a very busy slide. I'll not go through every bullet. I'll just talk about uh, why we now say we are a true SBC, single board computer. Whatever you saw with the Rubik Pi or the IQ9 boards in last 2 days, why we say it's a true SBC. So these are, we use the term touch point. Touch point for us means wherever some developer would come and interact with our software or our hardware in such a way that they would just expect it to work. That's what we call touch point, and that's like a interface you can't break. You can't change its behavior because that expectation is set for the developer by the larger community that is there. For example, if somebody is really using Ubuntu on laptops or other boards, they would expect a certain behavior. So let's go through this touch point. So building BSP, under this touch point, you would see what is written down here is one of the things that people do expect is I should be able to build the kernel on the board and deploy it and test it. I do want to modify it. I do want to experiment something. That's the goal of this touch point. And if you read through it, now you can build the kernel from the source that you clone on the SBC that you play with. You can change the grub configuration to even start at boot time the kernel that you built. Reason obvious, it's flexibility and development is for the developer who is playing with the board, and it empowers you to experiment. That's the intent. And in the demos, if you have seen, one of the boards IQ9 was running Ubuntu. So that's the touch point of developing the VSP using packages from PPA. So as we saw, we have a Qualcomm PPA on Launchpad, which has CamX, Adreno, and all these various packages which are supported by Qualcomm for for our camera IP, for our graphics IP. So if let's say you install the desktop image, obviously you will get some default upstream packages. That's what Ubuntu comes with. But then after running a bit of experiments and reading some specs, some documentation from Qualcomm, you come to a conclusion, hey, I would like to experiment once with Adreno. I would like to see, does my use case do better or worse if I use Adreno? So you don't need to grapple around to really find where is Adreno. There's a second touch point. People expect that there is a PPA which I can just add and I can install the package and I can get going. So that's what this PPA use case is for. So every package that we have, which we have improved in last 1 year and hosted in Launchpad, PP can be installed just like you would install any other package for any other from any other PPA. Uh, you can then clone your own software or any third-party software and compile it on the device. Let's say if you want to change something somewhere and use a uh, header from a CamX package, then you can install the CamX dev package and include it and compile it on the device and run your experiment. You can customize, optimize. Now it's open field, right? You can go about doing anything that you think is the right application that you're going after. You can achieve that. And obviously, while doing this, you can leverage any other open source project. You're not tied down by what just Qualcomm defines because you have moved over to the Ubuntu ecosystem. And then larger uh, thought process here is this is the third touch point. We know there are developers who may be working at the bleeding edge. They may be working on a project, contributing on a project which has not even made to the Debian Salsa and the PPA yet. They are working to get it included. So they would like to be in a position where they can include the project, experiment with their own project repo that they have in GitHub on this SBC. So there's nothing stopping you. This third touch point which we have kept in mind, and that is where Ubuntu by default comes into play with its development tools. And also all those use cases are something we feel that now enables you as a developer to explore our SBCs for as much as use as you like. So that's my presentation. Thank you, and questions please. Yes, sir.
Yeah. So, so as I'm interested in AML also, apart from Ubuntu and all these sort of things, so this sort of question is more about the application part of it. Like when you say SBC, right? Let's say I have uh, I have some I have some LLMs running in parallel. Let's say
Mm-hmm.
3 to 4 LLMs, and I have a single board where I have let's say 4 to 5 users running on heavy load. So then how do you manage the load so that the temperature won't rise and you get system lag performance, where the performance of the system lags. For example, the temperature rises 40 to 45 degrees centigrade, or let's say it touches somewhere around 70 to 75 on the higher end. So system naturally lags. So the response naturally lags because of the ongoing computational parameters problem. So how do you plan to tackle it? Like,
Great question. First thing which I'll touch upon is now IQ9 platforms that we're creating obviously are capable of working on a higher thermal envelope. That's what we are really targeting. But I understand what you're asking is what is the software mitigation plan. So what I'm not showing here, but is part of the Qualcomm offering is we do have thermal mitigation frameworks which can actually be installed, and those thermal mitigation frameworks take care of scaling the frequency and changing the governor allocation at runtime to ensure that when these kind of incidents occur, at least the hardware is really not stretched so much that it results in eventually burning out of the hardware too early.
no, it's not about the burnout. Let's say, for example, the fan runs too hard and the system lacks in performance, like to get the computational output.
Mhm.
So that's where my touch point is like.
Okay, I think what you are asking, we do have some frameworks coming out for that. I won't be in a position to announce them, but under the Qualcomm Linux umbrella, if you keep watching, we have some specific resource management frameworks that are going to come out to manage the performance expectations. And these kind of expectations, we have our learnings from our phone programs, Android programs, and compute programs, and we do realize eventually developers adopt and go towards commercialization, they would expect similar mitigation strategies or balancing strategies to also play out on a dev board, right?
Yeah.
So we do have those frameworks in pipeline, and that is something you can expect to see coming up under our Qualcomm Lux simulator. That's one of the key reasons I'm pitching. Please go and keep checking Qualcomm Lux, maybe subscribe to it, so that whenever a new repo opens up, goes public, you can go and read, and if required, even raise an issue, ask some questions. That would really make us happy.
Sure, sir. Sure, sir. Thanks.
Great question. And yes, I think Qualcomm realizes what you're asking is a real world problem. We have solved it for phones and compute platforms, and this is something we foresee as a need for even dev boards or IoT kind of platforms.
Thank you, sir. Begging. Thanks a lot.
Any more questions? Okay. Thank you, everyone.